And welcome back to our last podcast in our water pollution unit, where we're going to take a look at how we can deal with water pollution, as well as taking a look at how septic systems and wastewater treatment systems work. Obviously, the best way to deal with water pollution is to prevent it. That's always the best solution. However, once you do have it, working with nature to treat sewage can be beneficial. And always taking a look at how the earth deals with these problems is a good way for humans to look at how we can deal with our problems. Trying to reduce the flow of pollution from the land. Of course, all ocean pollution does come from land, or most of it does anyway, and so trying to reduce the amount that comes off our land, both solid and airborne. And believe it or not, this is really linked to our energy and climate policy. A lot of this has to do with petroleum-based products, whether it's the oil itself or plastics. And so if we are weaning ourselves off of a petroleum-based economy, that would greatly reduce the amount of oil that can flow into the ocean, as well as getting away from plastics and using more recyclable types of materials. Now, if we're looking at coastal water pollution, again, coastal in terms of the ocean, one of the things that we can do is we can separate our sewage and our stormwater lines. We're going to show you how a wastewater treatment plant works here in a little bit. We also actually take a field trip later on in the course to a wastewater treatment plant. But one of the things that can happen is when you combine your sewage, which of course is what goes down your toilets and your drains, from the stormwater, which runs off the roads into the gutters, if that's all in one system and you get a really hard rain, sometimes you overwhelm the wastewater treatment plant and they literally have to open up the doors and allow all the water, which includes the stormwater and the raw sewage, right into the waterways. And so if you have a separate system, then you can deal with the stormwater separately, particularly during hard rains. Another thing that you can do is you can require secondary treatment of coastal sewage. In some cases, they only require the primary, which is going to be the physical separation. But the secondary, that's also going to require the bacterial action to try to reduce the amount of materials, which include nitrates and phosphates, out of the water. Utilizing wetlands and other natural methods to treat sewage can be beneficial as well, because the wetland plants can extract the nitrates and phosphates. They can also store some of the toxic metals within the biomass of the plants, and then out the other side of the wetland comes clear, purified water. Banning of dumping of waste and sewage by ships in coastal waters, where you got a lot of cruise liners, you have a lot of freighters and whatnot, and they have a lot of waste material that they have to dispose of. And so the outright banning of the dumping, now they do have to have a permit to dump, but that oftentimes that comes to the enforcement, who's watching and who's enforcing. Strictly regulating coastal development, oil drilling, and oil shipping, particularly in the Gulf of Mexico, along the East Coast, and off the coast of Alaska, in the Arctic. There's a lot of oil. A lot of people want to get to that oil. So regulating the developments of those areas, and then regulating the drilling and the shipping of oil throughout those areas. And as mentioned before, requiring double hulls and oil tankers so that if they do run aground, the oil is still trapped within the ship itself. And then dealing with the oil spills, because they are going to happen. We still have runoff from land. Improving our oil cleanup capabilities, including use of nanotechnology. Nanotechnology has a lot of promise in fixing a lot of problems that we will discuss in this class. And so looking at how we can better clean up our oil spills will be to our advantage. Agriculture being the largest industry, we need to address erosion, fertilizer, pesticides. And a lot of this comes down to the planting of buffer zones so that there's a riparian zone between fields and waterways. Also the use of cover crops, which is advocated in organic farming. Lots of farmers do this nowadays, but between the two of them and being a little more judicious with our pesticide use, we can help reduce the amount of non-point source pollution getting into our waterways. We've mentioned previously that our point source pollution is going to be taken care of through our Clean Water Act, which controls discharge through a permit system through the National Pollutant Discharge Elimination System. The 1987, this is actually showing a historical development of the Act, where the 1972 Act was the one that actually gave teeth to the Act. The 87 Act simply allows and experimented with using market forces to trade discharging capabilities between different polluters. And we'll talk more about that individually in class. So let's talk about how we reduce our water pollution, particularly with our sewage treatment. So we're going to talk about both septic tanks and wastewater treatment plants. So in terms of septic tanks, this is predominantly used in rural areas where when people flush their toilets or whatever's going down your sink and shower drains, that goes out the house to a septic tank and then to a septic field. Now, what the septic tank is, it's just a box, and what happens is all the solid and liquid waste that comes out there, it's going to be chewed up by bacteria. And so the bacteria turns it into a gas, and you vent the gas out. And then there's always going to be some solid sludge waste behind, and so as the septic tank fills up, you actually have to come in and have somebody pump that sludge out of there. Now the liquid wastewater ends up going to out the box, out the septic tank, and into your septic field, where it's just simply leaked out into the field through perforated pipes, and then is taken up by plants, etc. You do have to be careful with septic tanks. You have to maintain the bacteria there. So you can't just pour it. You have to be very careful what types of drain cleaners that you use. If you pour bleach down the drain, for example, that would kill all the bacteria, and then that's gonna fill up very, very quickly. The sludge will not be decomposed, and you'll get a backup into your house of sewage. You also have to maintain your bacteria, and there's products you can buy at the store. Rid-X is one of them that you pour down the drain, and that helps seed the bacteria in the septic tank to try to help maintain the health of that system. So that's one way that we use in rural areas. Now with wastewater treatments, I'm just backing up here. There are 3 stages. Some people just use it in 2 stages, but we'll talk about it in terms of 3 stages. You have a primary, secondary, and tertiary. Your primary is going to be your physical process. Your secondary is going to be your biological, and your tertiary is going to be your chemical stages. So let's take a look at that. So in your primary stage, what's going to happen when raw sewage comes in, and sometimes this is with stormwater, they have these bar screens to screen out all the big stuff. And big stuff, we're talking about sticks, and we're talking about shoes, you're talking about cell phones, lumber. You'd be surprised, and when you go on the field trip, you'll see all the different stuff that comes through the sewer lines. And then you're going to have to, again, this is all physical separation, so then what happens is the solid waste goes into the settling tanks, and it just sinks to the bottom. And as it sinks to the bottom, that can be transported to a digester, and that digester is where you're going to be using bacteria to help break that down into a sludge, and then that sludge is going to be dried out and shipped to a landfill, or some people will actually put it on croplands. But this primary is going to be all physical. It's all based on density and screening out and settling to the bottom of the tank. Now, in the secondary treatment, that's where you use the bacteria to help chew up the solid materials and to get rid of the nitrates and the phosphates. And so the wastewater treatment plant is actually going to manage the amount of bacteria that's in there and help bring in oxygen and try to keep food in there for it, etc., which is actually the sewage waste. But it's bacteria management. And there's a lot of bubbling that occurs because there's a lot of gas that comes off from those bacteria, etc. And so then from there, and some people will classify this last step as a tertiary, this diagram does not, then you have to disinfect it. And the disinfecting is usually chlorine or ozone or UV light. And all of that has to take place to kill the bacteria before it gets discharged to the river or the lake. Now, this is not the drinking water. This is all the sewage water. And so in most places in the U.S., this is a separate process from the drinking. Your sewage gets treated and then gets dumped into a waterway. Now, whatever gets dumped into the waterway, that's all regulated by the Clean Water Act. It has to follow, and it has to be up to a certain specs in order to be dumped into the river. And it's usually much cleaner than the river or lake water itself. And then in a different location, different water will be piped into the drinking water treatment plant, and we've already taken a look at that. There are exemptions from secondary treatment depending on the municipality, and many would argue that those exemptions should not be allowed. The fact that all wastewater treatment plants must operate in the same way and actually go through both physical and biological treatments. Some also would suggest that we remove toxic waste before they go to sewage treatment plants, because the deal is that these treatment plants do not remove toxic metals. If there's copper, lead, mercury, etc., that the wastewater treatment plant cannot remove those types of things. If they get trapped in some of the sludge, then it could potentially reduce it, but they're not outfitted. It's all about the removal of the organics, the solid waste that go down our toilets, etc. All right. Developed countries such as the U.S., we require bottom-up political pressure to pass laws to prevent water pollution, whereas developing countries, there's not a whole lot that actually gets done to reduce water pollution, and that's where some of the foreign aid would come into play for that. So, what are some of the solutions here? Well, we do need to prevent groundwater contamination, and we've talked about the various sources of those. Non-point runoff, which is so difficult to both regulate and to manage, but it is a huge problem, particularly with sedimentation and the phosphate runoffs into our lakes. Treating sewage and reusing that wastewater to use for irrigation. Finding substitutes for toxic pollutants. One of the best ways to treat these things is just to prevent it. And so if we can actually find substitutes for these toxic materials, that actually would be the best practice. Following the 4 R's of refusing to use something, reducing what we use, reusing what's out there, and recycling what we can't would prevent water pollution. Don't forget about air pollution. Half the mercury that falls into the Great Lakes actually comes from the atmosphere. Reducing poverty, particularly in the lesser developed countries, because because of their financial and economic situation, they don't have the infrastructure to deal with water pollution. And as always, slowing population growth, which already has happened. Personally, what you can do is when you fertilize your gardens using manure or compost, minimizing the amount of pesticides that we use, preventing yard waste from entering storm drains. You want to mulch those and not discharge them into our storm drains. Trying to reduce the amount that goes down our toilets. Not flushing medicines down the toilets that actually end up into our waterways. And then not using the toilets in our sinks as a disposal unit. Most counties, or many counties, will actually have chemical disposal days, and so where you can bring your pesticides, your solvents, your paints, etc., so those don't end up into our drinking water or in our groundwater. All right. So we thank you for listening to these podcasts, and we'll see you in class.